Hello and welcome to another Leetcode video. Today we're looking at the meta tag problem minimum remove to make valid parentheses. This is another really cool parentheses problem that is pretty helpful to understand and really know how it works. So basically the task is that we're given a string of parentheses characters, opening and closing, and also lowercase English characters. We want to remove the minimum number of parentheses, either opening or closing, in any position so the resulting parentheses string is valid, then we want to return that valid string. So the definition of a valid string is a little confusing here, but I'll kind of break it down. So one valid case is a completely empty string. This is technically valid. Otherwise, there are really two main rules that you have to think about. We can never have opening brackets that are unclosed, right? So you see here there's two opening and one closing. This is technically not valid because every opening bracket has to have a corresponding closing bracket. So to make this valid, we'd have to remove one of these opening here. Another rule is that we can never have more closing brackets than we have open at any time. So if at any time we are adding a closing parentheses, but we don't have a corresponding opening we can join it with, we know that we have to remove this because there's no way this can ever be part of a valid parentheses string. So really just two rules you have to remember. One, make sure that all opening parentheses have a corresponding closing parentheses. We can't leave them open. Also, we have to make sure that we never add closing parentheses when we have more closing than open, right? So we can never have more closing at any time than we have open. So let's look at this example here. We'll see we have this Leetcode with an open, open, close, close, close. What we actually end up doing is just removing this last close here to make it valid. And this is because we actually have two valid pairs of parentheses in this string. So you see we could match this one before the T with this after the O, and then this one before and after the C, and then that really just leaves this final one here that's unmatched. So let's walk through this example a bit closer and see exactly how we could solve this. So whenever we're dealing with these parentheses problems, it's always good to think about stacks, right? A lot of these problems relate really well to stack because of the nature of popping and pushing onto stacks. And you'll kind of see as we go through exactly how this might work. So what we want to do here is keep track of parentheses that we've seen in this stack. And there's three rules that we want to follow. So one, if it's open, then we push, right? Anytime we see an opening parentheses, we're just going to push it onto our stack and leave it there. Our second case is if we have a close. So if we have a closing bracket, and then let's have 2a, if there's an open on stack. So if we ever see a closing bracket and we have an open bracket at the top of the stack, what we can essentially do is take that open on top of the stack and the close we're looking at and make those a valid pair. Essentially what we do is we just kind of ignore them. We say this is valid, and we're just going to worry about the other parentheses around this. Because we found this pair, we can kind of ignore it and look at other ones. So what we do here to kind of ignore it is we pop the open off the top of the stack, right? And we just move on. So we're essentially saying we're popping that open off. We're not putting this close on. So in that case, we're just kind of getting rid of the pair and ignoring them. The other case is if there's nothing on the stack. So if our stack is ever empty, and what this means is that at this case, we have more closed than open, right? So we have more of these closing than we have of the open. And as we said, we can't have this. This is an invalid string. We know that we can never have more closing at any time than we have open. And we have more closed than open because all the opens have either been popped off because they've been matched with previous closing brackets. So if our stack is ever empty, this either means that we've matched all the previous pairs or that we haven't seen anything yet. So just remember also that if we ever have a close and our stack is empty, we have to remove. We have to remove this because there's no way it can be part of a valid string. So if we ever see a closing and we have an empty stack, then we know that this is one that we absolutely must remove. So let's kind of walk through the example and see exactly what's going to happen. So first, we'll have this open here, so we push it onto our stack. We go to this next one, we push it onto our stack. So now we see a close. What case does this hit? So we do have a close, and there is an open on top of our stack. So essentially what we do is we just pop off this opening one. And this means that we've matched that pair. We don't have to consider it anymore as we're going forward. So now we go to this close, we see that we do have an open here. We hit 2A again, so we can pop this off, remove that. So now we get to this final close. And what happens here? So we go to 2, we do have a closing bracket, but our stack is empty, right? So we know that we can never include this as part of a valid parentheses string. So we know that we have to remove this one, right? So we can add, in this case, 1 to our toRemove variable that we're tracking. So that's kind of the logic of how we figure out what parentheses we want to remove, but how do we do this with this string? Well, essentially what we do is whenever we remove, we just keep track of what index that parentheses string happens at, right? So say we're removing this string at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'd have our set that we're adding index 12 to. So essentially what we're doing in this case is whenever we see a string that we have to remove, we add as index to a set. Then what we do at the end is we go through and we rebuild this string, but whenever we see an index that is in this set, we just don't include it. And this will allow us to get our final string. So one more thing that I want to go through is, what if we have something like this, right? What if instead of a closing, we actually had an open here? So we'd actually end with our stack having an open bracket on it, right? Is this okay? Well, it's not. As we said earlier, every opening parentheses must have a matching closing parentheses. This is not valid. This must have a matching close. So what we do here is, if there's anything left on the stack, and remember, this will only be open or left opening brackets on the stack at the end, we pop these off and add this into our set. So if we did have this here, we just have to go through at the end and pop any remaining elements off our stack and make sure we don't include them. So this whole operation takes O of n time. Since we're going through the string once and at most looking at each element twice when we insert it and when we pop it, and it's going to take also O of n space. So overall, a pretty efficient algorithm. So let's hop over to the code and see exactly how this is going to work. So the first thing we do is set up our stack and our toRemove set. So the stack is where we're going to keep track of parentheses that we've seen and be able to match and pop off pairs. This toRemove set is what we're going to use to keep track of indices that must not be in our final string. So here we outline the 3 cases. So we're going to go through our string, and for each index and character, we're going to go through them. If the character is an opening parentheses, we're just going to add it onto our stack. Otherwise, if it's a closing parentheses and the last element on our stack is open, this means that we found a valid pair that we can remove. So we're going to pop off this opening and not add the closing to the stack. So essentially, we're removing that whole pair from consideration. The other case is where we have a closing parentheses, but our stack is empty. In this case, we know that we cannot have this as part of our final string, so we have to remove it. So what we do is we add that index into our set. So then after we get through that loop, this is the case where we might get to the end, but have open brackets that are still left that we have to close, right? So we can't have these as part of our string, so we also just pop them all off the stack and add them to our set. Then what we do is we're going to build up this new string. We're going to iterate through the string again, but if the index is in our toRemove set, we just continue past it and we do not add it onto our new string. Otherwise, we just add it. So let's submit this and see if it works. And this does work. So this is another pretty cool parentheses problem asked by Meta. Definitely a good one to really understand. So hopefully this is helpful, and thank you for watching.